Hi, this is the second part of the 2D to 3D course, and is intended to acquaint you with modeling. Let's get started. There are several ways to create 3D models in Cinema 4D. Modeling with primitives, spline modeling, polygonal modeling, and modeling for subdivision surface. The simplest method is using primitives. Of course, you can't make super complex models with them, but they are still often used one way or another, especially in motion design. Very cool compositions can be created from primitives. Spline modeling uses objects of more complex shapes. They are assembled using splines and generators, which directly create a 3D model by extrusion or a rotation body. These models can also be modified with various deformers. Polygonal modeling. These are models created by one of the above methods, which are converted into editable objects and modified manually, or those created from scratch based on a simple shape or a single polygon. Most often, a primitive is converted and manually modified at the polygonal level. When converting, you fix the shape and number of polygons of the model. This is an irreversible process, that is, you cannot convert a polygonal object back to a parametric one. Modeling for subdivision surface. At the instrumentation level, this method practically does not differ from polygonal modeling, but it has its own subtleties and nuances of working with the model's topology. SDS subdivides the mesh into new polygons, increasing the level of detail and smoothing the geometry. This method is often used when creating any technical details, organics, characters, and more. All types of modeling one way or another are finalized by modifiers and generators. To achieve the desired result and speed up the process of creating a model, all these methods are often combined with each other. Now let's take a closer look at the primitives. The primitives can be found in this panel. When an object is created, it is added to the Object Manager. Let's create a primitive cube. When it is selected, information about this object shows up in the Attribute Manager. The first two tabs display basic information about the object. This applies not only to primitives, but also to all other Cinema 4D objects. The Basic tab essentially duplicates the information found in the Object Manager, such as object name, layers, and display. We can also set the model's color, for convenience, and apply the transparency mode of the object. In particular, there is the X-ray command that only works on the selected object. The next tab is Coord. It displays the object's local coordinates, such as position, size, and rotation. Object tab. It displays various settings for the object. In this case, the size, number of subdivisions, and fillet settings. For each object, these settings and the number of tabs will be different. The Fung tab is a standard tag that is created with primitives. The Anti-Aliasing tag is a built-in Cinema 4D feature that creates a perfect surface from an object with sharp edges by anti-aliasing. This is clearly seen in the example of the sphere. With the tag enabled, the sphere looks perfect. But when we remove it, we see the edges of the model. The next primitive is null object. A null object is intended for grouping scene objects. It is initially displayed as a dot. You can assign to it one of the shapes to display it in the viewport and set the color in the Basic tab. It is also used to create controllers during rigging. Sphere primitive. The Object tab has settings for radius, segmentation, and polygon subdivision variations. The Render Perfect button is responsible for displaying the ideal sphere on the render, regardless of the number of segments in the object's settings. As for the subdivisions of objects, you need to understand that the larger the shot, the more the segmentation of the object must be in order to display it correctly. If the object is in the middle or long shots, the segmentation can be reduced to improve the performance of the program. So you should always adjust the optimal polygon count. Cone primitive. The Object tab displays the settings for the size and segmentation of the object. In addition to size and segmentation settings, it has a tab with caps settings. These are the caps at the top and bottom of the object. These can be turned off. Also in this tab, roundings can be adjusted. When enabled, additional interpolations appear on the model, which are convenient for adjusting the strength of the rounding. The Slice tab allows you to cut an object like a pie. All objects have this parameter, bodies of rotation. The regular grid parameter adjusts the model's segmentation in these areas. Cylinder object has almost identical settings, such as size, segmentation, caps, and rounding. Like other objects, they have interpolators to adjust the size or rounding of the object. The next object is Capsule. The Object tab displays settings for size, segmentation, and orientation in space. There is a parameter for configuring the segmentation of caps. Oil tank. Here almost everything is the same as with Capsule, but it additionally has the cap's height setting. Tube. It has settings for outer and inner diameter, height, and segmentation. There are also fillet settings. The next object is Torus. It has settings for radius, thickness, and segmentation. There is also a slice, which you use to cut off a part of the torus. Pyramid object. This object has fairly simple settings. Size and segmentation can be set. Platonic. It also has a small number of settings, such as size, segmentation, and type for the platonic solid object. Polygon. A flat object with a uniform segmentation setting. It also has settings for size, position in space, and it can be transformed into a triangle. Plane. This object differs from a polygon in that it has a separate setting for splitting along the sides. The next primitive is disk. It's a flat object that is a body of rotation. It has settings for the internal and external diameter. It has segmentation along and across the object, orientation in space, and slice. The next object is Bezier. The Bezier object is suitable for creating arched or curved surfaces. By default, it is a flat object that has segmentation settings. If switched to the point editing mode, we will get a grid, the settings of which are set in the grid point. Using these points, we can customize the needed shape. There are also settings that allow you to close the model. Landscape. This is the object for creating various unpretentious landscapes. In the settings, you can change the size, segmentation, and set different variations of the landscape. Now let's talk about deformers. The general essence of deformers is using them to get some new shapes. They can be applied in two ways. In modeling, to get some new curved surfaces, or in animation, that is, getting a shape change in the form of animation. As a reminder, all deformers are purple. The main ones are in this drop-down window. There are also MoGraph deformers, simulations, and characters. Let's take a look at the frequently used deformers. I want to say a few words about using deformers. It is very simple to apply deformers. Just make it a child of the object. In case you want to apply a deformer to several objects, you need to group them. Next, add a deformer to this group. When applying multiple deformers, keep a close eye on their hierarchy, as the lowest deformer affects the ones above. If I, for example, now change their order, then you see what the result is. So let's start with the bevel deformer. This is perhaps the most basic deformer in modeling. It is used very often. By default, this deformer creates chamfers on all faces of the model, but you can select from the available modes, points and polygons. In the points mode, chamfers are made from all points of the model, and in the polygons mode, the polygons are extruded and displaced. Accordingly, each mode has its own settings. For polygonal objects, it is possible to assign the scope of the deformer with a face selection tag. As an example, I will convert a cube to a polygon object. Switch to face editing mode. I will select the top edges and add them to the selection tab. To do this, go to Menu Select and select Set Selection. Depending on the selected mode and the selected part of the object, be it a point, face, or a polygon, a corresponding selection tag will be created. Now by clicking on it, the saved faces are selected. Add this tag to the selection parameter of our deformer. We can see how it is applied exclusively to the selected faces. There are also a few more important settings. Offset and subdivision. The first one is responsible for the radius of the fillet and the second one for the segmentation of the chamfer. In cases where the chamfer is too large and the geometry begins to intersect, this can be removed by ticking the limit. The depth parameter adjusts the profile of the chamfer. Always add chamfers to objects as they will immediately improve the appearance of the model. The next deformer is bend. Those who worked in After Effects remember the CC Bendit effect. This deformer creates the same effect. The scope of the deformer is indicated as a container. Its dimensions are specified in the size line. In the Model Edit mode, Deformer has an interactive point that you can use to adjust the bend. The most important thing to understand is how to position the deformer correctly in relation to your model. The deformer has two arrows. The large arrow along the y-axis indicates the direction in which the object will bend. The strength parameter is responsible for this. The small one shows in which direction the deformer will bend. This is the angle parameter. Thus, with the correct orientation, you will be able to bend the model. It is important that the model has enough polygons to deform. There is an automatic fit to parent mode that creates a container to fit the model. But be sure to set the axis alignment. For example, I need to bend a cube along the z-axis. On this axis, I have a certain segmentation set, which will allow me to bend the object. Next, I'll select the deformer and set the z-axis in the alignment parameter. Click Fit to Parent. The deformer object was oriented along the given axis relative to the parent object, and automatically created the dimensions of the box according to the object. By changing the angle parameter, you set the direction of the bend. By moving the deformer container as well as changing its size, you select its scope. The Mode tab has the deformer settings. In limited mode, the deformer affects the entire object. In this case, only those parts of the object that are within the container will be deformed. The Within Box mode. The deformer works only within the container. All surfaces outside of it will simply be trimmed. The Unlimited mode. In this mode, deformer affects the entire object, including the areas that are outside of the container. And the last parameter is Keep Length. It's a particularly important parameter as it allows you to keep the length of the object when bent. Next, let's take a look at the Twist deformer. Again, just like in After Effects, there was a similar effect called Twirl. Let's go back to the Twist deformer. It has similar settings as in the previous deformer, such as an interactive point, deformer force setting, the size of the container, the modes of its effect on the object, and the rotation angle. Deformation occurs along the y-axis of the twist object. And don't forget that to achieve correct deformation, you need a sufficient number of polygons. The next one is the Shear deformer. Those who worked in After Effects will find it somewhat similar to the CC slant effect. This deformer, like the previous ones, has a similar container setting and settings for the effect itself. The Strength parameter defines the intensity of the bend, which can also be determined interactively using the orange controller. The Angle parameter indicates the direction of the bend. The arrow in the container is also responsible for this. The Curvature parameter defines the appearance of the curvature. The higher the value, the more the bend will be. The Fillet parameter allows you to distort curvature. Bulge. It has the same container settings as the previous deformers. The deformer can expand and contract an object in the XZ plane relative to its center. This effect is called Warp in After Effects. The next deformer is Taper. It has the same container settings as well as deformation force, curvature settings, and fillet for curvature. By moving or rotating the deformer, you will affect the distortion of the model. The Squash and Stretch deformer. This deformer allows you to squash and stretch an object. The most important parameter is factor. The rest are responsible for various squash and stretch settings. It is more often used in animation rather than in modeling. Shrink Wrap. This tool allows you to morph one object into another through the projection of polygons. For example, we want to deform a cube into a platonic object. In the Target Object parameter, we indicate the object into which we want to morph the cube. In my case, this is platonic. Look at the Mode parameter. Along normals, mode is selected by default. In this mode, the object's normals will be applied to the object we are morphing into. For this to work, the number of polygons must match. So, Target Object is the most commonly used, and it uses the center of the platonic object. Accordingly, the Source Target mode uses the center of the deformable object. It is important to note that the object that we are deforming in any case must have a sufficient number of polygons. The Surface deformer. The projection mode allows you to attach an object to any model. For example, we have a character's hand and clothing. For close, we use a deformer. And in the surface parameter, we set the object to which we want to parent the model. Remember that the type is projection. Click the Initialize button to enable the effect. When the prototype of the hand is moving, the clothing follows it. In the Mapping UV mode, the object is projected using UV coordinates. Using the sliders, you can adjust its position on the projection. The next one is the collision deformer. This deformer is used to create a simulation of the interaction between objects. Make the deformer a child of the object you want to deform. In the Colliders tab, specify the object that will interact with it. Now, by moving the collider object, we observe how they interact. In the Object tab, there are various interaction settings for an object. You can configure how the shape is saved. For this, set the Restore Shape parameter to 0. To see the changes, you need to start the timeline. As I said, add an object that will deform the mesh to the Colliders tab. There is also a setting for how the deformation will work. Inside means that the object will act from the negative side of the normals. Inside Stretch works from the same side, but additionally stretches the mesh. The Outside mode works from the outside. Modes without stretching affect the object as long as it intersects the plane. Include tab allows you to specify group objects that will be affected by the deformer. I'll create some additional objects. Add deformable objects to the group. Drag and drop the deformer into it. And now it works for all objects. But if you need to influence specific objects from the group, place them in the Include tab. So we can see that the object that we did not add to the Include tab is ignored. Let's consider the Spline Wrap deformer. This deformer is used very often in animation. It allows you to move any object along the spline. We have an object that we want to move along a spline. Let it be text. Apply the deformer to it. We create a spline. It does not matter whether it is drawn by hand or if it is a primitive. We indicate this spline in a deformer. We drag the object to the spline line. Next, we indicate the direction of the deformer. The arrow shows the object's direction along the spline. The deformer has several important parameters. Mode, Fit Spline is selected by default, in which the object is stretched along the length of the spline. Keep Length keeps its original length. The Offset parameter allows you to move the object along the spline. And the From To parameters define the spline segment which the deformations will really affect. There are also settings for the size and rotation of the object along the spline. End Mode parameter. In the Extend mode, adjusting the offset slider will move the object outside the spline. If you switch to Clamp, the object will be clipped, but it will not disappear completely and the geometry will be visible. In the Rail tab, you can add a guide spline that will affect how the object is rotated. I'll duplicate the spline and name it Spline Rail. I drag and drop it into the Rail deformer line. Now by changing the position of the spline, we can see the text follows it. The Spline Deformer. It allows you to distort the model using splines. How does it work? we create a spline in the same plane as our model. In my case, the model is plane. Duplicate the spline. Next, add one spline to the original Spline tab, and the second one to Modifying. It is also advisable to name them so as to not get confused. Now, if we move the Modifying spline, we observe how the model deforms. Let's take a look at the deformer settings. The B-spline approximation parameter determines the degree of subdivision of the spline, but it only works for splines of the same type. Using the radius parameter, the deformation radius is adjusted. The use length parameter is used if the splines have a different number of points. At the same time, the algorithm of the program produces a uniform distribution of points to ensure a smooth deformation process. I changed the type of spline. Now they have a different number of points. Checking Use Length checkbox, we see small changes in the deformation, but it still doesn't look very good. So turn on the Full Polygons mode. In this case, when performing the deformation process, not only points but also polygons will be taken into account. Due to this, the deformation looks smoother. Shape allows you to create a distortion profile, but there must be a sufficient number of polygons on the model for complex deformations. Jiggle. The deformer is used in animation to create damped vibrations. Those who worked in After Effects probably remember what it is. And so for the deformer to work, the object must be animated. Let's create two position keyframes. We play the animation by clicking on the play button. The main deformer settings are located in the Object tab. The OnStopped parameter. When disabled, the jiggle deformer works throughout the animation. But if you enable OnStopped, the deformer will only work after the object has completely stopped. The ticked local checkbox is responsible for the fact that the deformer will only affect changes in the local coordinates of the object. Global coordinates animation will not be counted. For example, I will animate the size of the object. Now tick the local checkbox. We see that the position does not have any damped fluctuations. They occur only in size. The strength parameter is responsible for the strength of the deformer. Stiffness determines how quickly the points of the deformed object should return to rest. Structural is also responsible for wiggling, but for the secondary ones, which return the object to its original position. Now the length of the composition is not enough to see smooth, damped oscillations, so I'll add some frames. The drag function determines the air resistance. The more drag there is, the smoother the swing. Springs sets the number of springs that create vibrations. The larger the number, the slower the fluctuations. And the iterations parameter affects the change in the stiffness of the vibrations. Next, let's talk about Displacer. This deformer allows you to distort a mesh based on a shader. But it is very demanding in terms of the grid. You must have a large enough number of polygons for the deformer to work correctly. Let's go to the Shading tab. Here you can select the channel by which the distortion data will be taken into account, or set your own material for this purpose. Standard textures are most often used. Set noise in the shader line. Click on the arrow and select a texture from the drop-down list. You can animate it or upload your own animated textures. In the Object tab, the main settings are strength, the magnitude of the effect, and the height of the distortion. Wrap. It's also a fairly simple deformer. It allows you to wrap an object onto a cylindrical or spherical shape. It has two customizable containers. The flat one is responsible for the size of the original surface, and the second one for the surface which the object will be wrapped on. All of these sizes are configurable in the Object tab. You can also adjust the projected part of a cylinder or sphere. In this case, we have the cylinder, and we have two parameters: longitude start and end. You can also adjust the offset, thickness, and strength of the deformer. There is also fit to parent, which creates a container according to the size of the object. The wind deformer. It allows you to create wave deformations of an object. For those who worked in After Effects, there was a similar effect called wave warp or ripple. Wind deforms the surface along the z-axis. Distortion works relative to the center of the deformer axis. It has amplitude and wavelength settings. Frequency. So the higher the frequency, the faster the wave moves. There are turbulence settings and additional distortions. The flag parameter. If you turn it off, then the deformer will work evenly throughout the model, regardless of the location of the center of the deformer. FFD. It allows you to distort an object by changing the 3D mesh set in the deformer. After adding it to the object, apply Fit to Parent and adjust the deformer mesh. The larger the deformer mesh, the smoother the curves will be. It is done in the point editing mode. By shifting the points, we set the desired deformation of the object. Mesh. This deformer is similar to FFD, but using it, you can create your own mesh, along which the object will be distorted. Mesh is used to deform a complex model at the expense of a simpler one. It is also used in animation when you need to create dynamics. On high-poly objects, it is difficult to calculate, so a simpler mesh is used that will deform a complex object. Apply the deformer to a high-poly object. In the Object tab, place a low-polygon object. It will be used to determine the deformation of the previous one. Click the Initialize button. Tags appeared on the object that tied it to the deformable. Now all control is done through it. In order to make any kind of deformation, you need to convert the low-poly object and, in the point editing mode, do the deformation. The deformer also has settings for calculating weights and effects of the container. As I said earlier, it is applied dynamically. For this, the object does not need to be converted to a mesh. I will switch it back to parametric by pressing Ctrl-Z several times. I will add the soft body simulation tag to the cube. Create a plane, add the collider body tag to it. Now, when we play the animation, we can see that the object falls and deforms. Due to the small number of polygons, this works pretty quickly. The next deformer is smoothing. The deformer allows you to smooth the surface of the model. Basic setting, strength of anti-aliasing, and number of anti-aliasing iterations. The stiffness parameter is responsible for the strength of the smoothing, taking into account the stiffness map parameter. And the last deformer we'll look at is Spherify. It lets you turn a simple object into a sphere. It has only two settings, the force of deformation and the diameter of the sphere. But if you apply falloff, you can get such an interesting effect. Now let's learn more about falloff or fields. Fields are objects that limit the effects of deformers with their shape. After clicking this button, a list with various field objects appears. As I said, they apply to almost all deformers. If it has a falloff tab, then we can add a field object to it and limit the effects of the deformer. Also, any object can be used as a field. For this, it is enough to move it to the falloff tab. Let's see how it works on the example of a landscape with the displacer deformer. I want to limit the effects of the deformer. This can be done in the falloff tab. Holding down the pink button brings up a menu with a choice of fields. Or we can select an object from this menu. The hierarchy in the object manager is not important, as fields can be anywhere. The main thing is that the objects are added to the falloff tab. Let's take a look at the linear field. We see two planes and an arrow that shows the direction in which the deformer effects will increase. The distance between the planes sets the smoothness of the transition. The field object has its own settings. The first two tabs are the parameters of position, rotation, and size, like all objects. The field tab has a menu for selecting the type of object. Depending on the selected object, there will be corresponding settings. In this case, we have a linear object. We can adjust the distance between the planes and its direction. The Remapping tab allows you to configure the transition, its profile, the maximum and minimum field values. Now I will create a box field. Let's add it. The linear field has stopped working since the box field blocked it. If we turn on the Add Blending mode for box field, they'll work. That is, we have the opportunity to work with them as with layers in Photoshop. Note that the box field has a small cube, which is marked by a dimmer color. This is exactly the area that is responsible for smoothing the transition. If I scale up this cube, we see an abrupt transition. This can be done using interactive points or use the inner offset parameter in the Remapping tab. Every field object has this setting. This menu also has layers. Layers are the elements that use information from other objects. All of them are here in this list. Let's consider a spline object as an example. Let's create a spline in the landscape plane. Next, in the deformer, select Layer Spline, and click on the created spline. It is automatically added to the list of the field objects. You can simply transfer the spline object to falloff. The Blending tab duplicates parameters in the list of fields objects. The Layer tab displays layer settings. In our case, for the spline to work in distance mode, you need to select the radius mode and increase the values of this parameter. The Object tab is directly related to the spline object. All its settings are duplicated in this tab. And the last tab, Remapping, is responsible for the transition profile. We already talked about this. Modifier layers. These are additional effects that can be applied to layers and objects. Let's add an invert effect, for example. All deformations were inverted. There is also a very cool opportunity to make a mask out of a field. Select a field, apply a mask to it, and put a field in it, which will affect the distortion. You can create many such combinations. The main thing is not to get confused in objects and hierarchy. For convenience, you can group effects into folders. The next part of the lesson will focus on generators.